Hello all, welcome to Dr. GV lecture series. I am Dr. Yuvaraj, Assistant Professor, Mechanical Department. So we are seeing the topic, it is about force analysis, and in specific we are dealing about the free forced vibration. So in that aspect we come across what is meant by D'Alembert's principle, what are the Newton's first law and second law states, and how we going to analyze the speed and the vibration and as well as the force analysis of the particular vehicle or the object. So based upon that we come across so many topics in that area. Okay, so in continuation with our previous session, today I am going to speak is about inertia force. So first of all, since we dealing about the vibration, we have to know what do you mean by inertia force. Behind the every vibration there is some invisible forces will be there. That forces is what do you call that inertia. So inertia is nothing but generally where we are experiencing the inertia. For example, if you are traveling in a bus, when a bus is suddenly applying the brake, okay, your body will experience a certain movement from your place, from where you are seated. Or if you are standing in the bus, your body will experience the sudden inertia, that jerk. Or else let us take in another scenario. You are traveling in a lift, okay, when the lift has reached your floor, okay, when it makes a moment of stop, your body will feel some sudden jerk. That jerk is what do you call that inertia. Inertia is it is a sudden movement, it is a sudden force. Okay, that's some sudden force or sudden movement, which is what do you call that inertia force. But in a rotational object we are experiencing this centrifugal force. Okay, but wherever in a linear moving object we are experiencing the inertia force. Okay, that inertia force is the very crucial component in the vibration analysis. So we have to embark or we have to arrest that inertia force by giving some damper or by giving some vibrational reducer or resistor. We need to add the installation in that way. Okay, so this is what this diagram shows with the example. So in the dynamic force analysis we have to do in the engine, we are doing the calculation of displacement, velocity, acceleration. For this thing we have to use the formula r into 1 minus cos theta plus sin 2 theta divided by 2n. And similarly we need to calculate about the velocity of the piston, and similarly we have to calculate acceleration and angular velocity of the connecting rod, angular acceleration of the connecting rod. So in all analysis we have to analyze the force moment of particular engine component moment. So based upon that we have to do their force analysis. So let me discuss one problem. For example, we are going to dealing about the dynamic force analysis of the specific engine component. So the given problem, it is about in a slider crank mechanism, length of the crank is 150 and connecting rod is 600, crank angle is 60, crank speed is 450 rpm, it is rotated in clockwise direction, and by using the analytical method we have to calculate what do you mean by velocity and what do you mean by acceleration. So we know that we have to use the formula. In our previous slide we having a formulas for this one. Okay, so here these are the formulas for displacement, velocity, acceleration, angular velocity and angular acceleration. So we need to use this formula. Velocity of the piston is equal to r into omega sin theta plus sin 2 theta divided by 2n, where n represents, it is what do you call that obliquity ratio. Obliquity ratio means it is the length of ratio between the crank and the connecting rod. Okay, this can be represented as an n. So we need to substitute this value, and accordingly you may calculate what is omega means. We know that it is an angular velocity, that is 2 pi n by 60. By substituting the values you may getting the answer, that is a velocity. If we know the velocity we can directly substitute the value for the acceleration, and finally you may calculate what is the velocity of the slider and what is the angular velocity of the slider. Accordingly we have to substitute these values, we may get the result. This is how we need to calculate. But it is about the motion analysis. But what about the case if you are using the force analysis or if you do the analysis in force, we have to use the different formula. So let me see in detail in another class. Thank you.